Welcome to Math with Mrs. Seeley. Let's get started on this 2024 free response question number 1. We're given this table and told that the temperature of coffee in a cup at time t minutes is modeled by a decreasing differential function c, where c of t is measured in degrees Celsius. Then from the time from 0 to 12, they give us some selected values. A part says to approximate C prime of 5 using the average rate of change over this interval from 3 to 7. We're going to show the work that leads to our answer and indicate our units of measure. If they're asking us to find the average rate of change, recall that that means the slope. So when we think about slope, think about your formula y2 minus y1 over x2 minus x1. They are asking us to find C prime of 5, or that rate of change at the 5-minute mark. So it would make sense that that falls between 3 and 7, which is why they told us to use the 3 and the 7. Remember, this is your x and this is your y. So I'm simply going to use my average rate of change or slope formula. So I'm going to say y sub 2, which is 69, minus y sub 1, which is 85, over x sub 1, which is 7, minus x sub 2, which is 3. All right, do your calculations. You do have your calculator for this one if you need it, but that's negative 16 over 4, which is negative 4, and that's your answer. If you get that, give yourself a point, but then it also says to give the units of measure. Remember that slope, that's your y's over your x's. So take your y words over your x words, and that's going to give you your units. So that would be degrees Celsius, and they want those degrees, so we're going to write those units, over minutes. So degrees Celsius per minute. If you get your units correctly, also give yourself one of those points for the total up to 9. The second one says to use a left Riemann sum. So we're going to use a left Riemann sum with 3 subintervals based on that table up there to approximate the value. So that's 0 to 12 of C of t, d of t. Remember that Riemann sums, that's like using rectangles to add those up. So we need a base height, the base height, or a delta x. It said left endpoints. So I'm going to check mark the left ones. I'm going to use this one, and this one, the 3 to the left. All right, in this first interval from 0 to 3, my delta x is 3. So that'll be 3 times 100, which is the left endpoint, plus, let's go back up here and find the delta x for the next one. So from 3 to 7, that's a distance of 4 units to go with that next left endpoint. So that's going to be 4 times 85 plus, go do the last one and find that delta x. So that's going to be from 7 to 12 is a delta x of 5 to go with that last left endpoint. So that's going to be 5 times 69. If you set up your Riemann sum correctly, give yourself another point. Then do your calculations, and we do have the calculator again for fast timing, and you get 985. And if you did that, give yourself the second point on that part of the question. All right, then it says to interpret the meaning of 1/12 that interval in context of this problem. Remember that when you have a fraction out there, that's always implying average rate of change. So it's going to be the average temperature of the coffee in degrees Celsius from time t is 0 to time t is equal to 12 minutes. If you got that interpretation correctly, give yourself a point. Now, there's a couple things that must be in here to get your point. They're non-negotiables for them. One is that you talk about average temperature. I mean, you need of the coffee in there, but if you leave out the word average temperature and if you leave out your time interval, they will not give you the points. Right? Next one C part. From 12 to 20, the rate of change of the temperature is modeled by this expression right here, where C prime of T again is measured in degrees Celsius per minute. We want to find the temperature at time T equals 20. And we got to show the setup for our calculation. So we want the temperature at T is equal to 20 minutes. Now let's think about what we have so far. The table they gave us up here clearly tells us what the temperature is at the 12-minute mark. So at 12 minutes, the temperature is sitting at 55. So therefore, we know that at the 12-minute mark, it's already 55 degrees. This is like your initial condition. If you used that initial condition, give yourself a point. So we know we're at 55 degrees at 12 minutes, but what's happening from 12 minutes to 20 minutes? That's the rest of it. Well, we're told that from 12 to 20, the rate of change is modeled by C prime of T. So we're going to integrate C prime of T dt over that 12 to 20 minute mark. If you knew to integrate that rate of change from 12 to 20, give yourself another point. Now remember, this is such a powerful, this is your net change theorem. And remember, if you ever integrate a rate of change, if you integrate a rate of change, you're going to get the net change. And so what that's saying, if I integrate the rate of that temperature, I'm going to know what the temperature actually was, what happened during that time. So then I'll just go to here and I have my 55. This right here is done using your calculator. You know that Math 9 button that allows you to fill in the boxes and put in your formula right there. So y'all know about that. You're going to put in your 12 here, your 20 here. You are carefully going to put that in there with the dx. When you do that, you're going to get negative 14.6708. Then you do your calculations and you get 40.329 degrees Celsius. Remember that the AP exam likes 3 decimal places to your rounding. If you got that answer, give yourself your next point. All right, then the last part says this. For the model defined in part C, so right here, what we just did, it's shown that the second derivative is equal to this from 12 to 20. And so the question says, determine whether the temperature of the coffee is changing at a decreasing rate or an increasing rate. So we want to know the rate of temperature that's going, is it increasing or decreasing? Is the rate increasing, which is the derivative. So we need to know if that derivative is positive or negative. So let's take our C double prime and let's put a value in there. It's up to you which one you do. I would do anything from 12 to 20. So I just plugged in, just say a 15. If I go plug a 15 into this equation where there's a time, get your value, I got that it was 0.1077. Basically, it's positive. So that means that second derivative is positive on the interval from 12 to 20. So if my second derivative or my rate of change is positive, it means the temperature is increasing or changing at an increasing rate. So the second derivative is positive on that interval. So therefore, the temperature of the coffee is changing at an increasing rate. Do you notice that I'm using the words from the question? I'm going back up here and I'm seeing determine whether the coffee is changing at a decreasing or increasing rate. I just kind of copied that over. The temperature of the coffee is changing at, in our case, increasing because the derivative was positive. If you were able to state that it's changing at an increasing rate and justify it by showing that the derivative or second derivative is positive, give yourself the last of those 9 points. I hope that you found this helpful in preparing for your AP exam. If you did, please like, comment, and subscribe to the channel, and be sure to check out other AP Calculus question explanations for free response, as well as other videos on the channel. See you next time.